I want to welcome everyone to the Basics of Wheelchair Racing Equipment series, where we will be focusing on cylinders and compensators today. My name is Lily Jagozinski from Move United, and we're super excited that this is our 5th session in this equipment series, and we appreciate everyone being here. I just wanted to remind you that this session will be recorded for people who are not able to join us currently, and all attendees are on mute just to minimize distractions. But if you have any questions, please feel free to click the Q&A box at the bottom of your screen, and you can ask questions throughout the entire session, and we'll hope to answer them later on this afternoon. All right, if you haven't already checked out our Move United Sport Adapt at Home page, we encourage you to check it out. We have a variety of programs there, from sport-specific things to more training and education, and we encourage you to tag us at Move United Sport and use the hashtag Adapt at Home to show us how you move. Now I'd like to introduce our panelists again. They've been here, they've been giving us great knowledge. We have Daniel Romanchuk, who is a world champion, Paralympian, and major marathon winner, as well as Krish Skabort. He's also a Paralympian, an SB winner, and an Ironman World Championship record holder. So thanks so much, guys, for being here again. And we are excited to have our special guest here as well. His name is Ernst van Dijk, and he is a 7-time Paralympian, multi-Paralympic Games medalist, 10-time Boston Marathon champion, and a 3-time UCI World Champion. So Ernst, thank you for joining us today, and we're excited to have you. Now I'd like to turn it over to Kim Romanchuk. She is Daniel's manager as well as an online science teacher, and she's going to be moderating our session today. So Kim, feel free to take it over.
All right. Well, thank you everybody for being with us. Today we are going to be covering a topic that most racers learn pretty quickly, how to use the basic functions of it. That is, how to get your chair to go a particular direction when you want it to. But oftentimes you don't really understand what goes on behind that to make it happen. Just kind of like you can drive a car and you know how to make it go somewhere. But then when something goes wrong, you got to take it to somebody who actually knows what they're doing and knows how it's supposed to work to fix it. And so not many mechanics for racing wheelchairs are around. So we want to talk through how all the different parts of the different steering components and all of that stuff works together so that the fixes make sense to you, and you're not left frustrated when something goes wrong and you have to think about it. So I know when Daniel started racing, I always thought there was some sort of magic that happened somewhere between that track control and the front wheel that made it turn all the time. I really never understood. It's like, oh, try screwing that thing this way. No, that way. No, the other side. I don't know. Just keep on doing something until it goes the way. And so it's been really interesting, and I'm deeply indebted to Krieger and to Daniel for being very patient with me and teaching me how this all works. But it's really cool once you understand it. And so I am going to be today playing the role of, I will be every once in a while when Daniel's presenting, I'll be interjecting some of the questions that I asked early on. So they may sound a little clueless, and that's because I was clueless at that point. Still am on a lot of things, but anyway, that'll be kind of the role that I'm playing. And so with that, I'm gonna switch my video around and we're gonna get started with just going over some of the very basics. And remember, this is supposed to be a beginning series. Not stop the video, turn the video around. Okay. There we go. There he is. He is here.
And so going over so just some of the basic things to begin with. The connection between the front fork / wheel and the main beam creates a joint, and that joint allows us to steer. So that's just like it is on a typical bike. However, unlike a bike, we cannot constantly have our hands on the steering because we need to be applying power to the rear wheels. And so if a regular cyclist were to let go of their steering, you can see I'm holding it, this is what would happen. That was anticlimactic. That is what will happen. And so we need something that is going to stabilize this joint and keep us going in a default direction. And when I say default direction, I mean, if I am just pushing along, I keep going in one direction and I never have to steer. And so that is done with this piece here. And so this is a cylinder, and it acts like a shock absorber and goes across this span right here, and will keep our front wheel going in one direction. And so on the inside of a cylinder, I have a disassembled cylinder here. On the inside, it is basically a metal rod with a spring over part of it. And that gets slid into this housing here, and a little bit of that rod sticks out the end. And when it is properly assembled, that rod, or that spring, is going to resist any attempts to push that rod into the housing or pull it out of the housing. So I've got a fully assembled cylinder here, and starting from the edges, you have on both ends, you have what are called rod ends, and these are basically the attachment points of the cylinder. Then you've got that housing that is right over top of that spring, and then there's that little bit of rod that is sticking out the end here. And so this cylinder is at its resting length right now. And when I mean that there are no forces attempting to push the rod ends closer together or pull them apart. If there are any forces, like I just tried to do, they will be instantaneously resisted by that spring that's inside of the housing here. So this will always likes to be at its resting length. So I have a fully assembled and installed cylinder here. It is attached on one end. It is clamped to the fork arm, and on the other end, it is anchored on the track control. And so if I am pushing along, and this is at its happy resting length right now. So if I'm pushing along and I see some bumps up ahead, I don't have to worry about those bumps pushing on my wheel and changing my direction, because I have this cylinder here, and that cylinder is going to, like I said, instantaneously resist any attempt to change the direction of my front wheel. And so I can just go right over those bumps without a problem. The one thing, though, sometimes is sometimes the wheel has a bit of play in it. It will move side to side without substantial force. And so for that, I'm actually going to hand it off to Kriega. So what's kind of going on there?
Hey, all right. Good explanation there, Daniel. As you say, there's a little bit of magic in the cylinder, this whole track control system. It's sometimes a little bit tricky, but I think that the only thing for you really to understand it is to play with your own equipment. You know, play around with it and see if you can, like Kim said, tighten here, loosen there. But I think these videos will be a really good help for you guys to make it a little bit simpler. So I'm going to ask my cameraman to come around, and so we can have a better view here for you guys to see what's going on. Okay, so you can be on the track or on the road, and you just feel like, man, there is something is not right. There's a click sound, or there's a movement, there's a play in a front wheel or in a steering, and you just don't know where it is. Where is it coming from? So we were talking about the cylinder now, so let's cover that for this topic now. So if you're gonna work on the play somewhere here in the cylinder, you're most likely gonna resolve it. So there are 3 points you're gonna check on your cylinder. Okay. So first, there are the 2 attachment points, one at the front and one here at the back, where it attached to the compensator or the track control. And then now 2 more. There's 2 little lock nuts that holds the cylinder basically in place with the two rod ends. And then there are two more, and those are these two big lock nuts. And they all look like they're perfectly in good shape now, and they probably are, but I'm gonna create a real quick scenario for you guys so you can see what happens when something is out, okay? So I'm gonna start on the outside, okay? So I'm gonna do this first. I'm just gonna unlock the lock nut at the bottom here, and I'm gonna give you an idea of what it's gonna, okay, listen now there. You hear that? And so a lot of times you cannot even see where it's from. You hear it, but you just can't figure out how to fix it. So I would say always start at the two outer points first, okay? So, okay, I'm gonna go today and I'm gonna do the back one first. There's a lock nut at the bottom here by the attachment point. And I'm gonna tighten, okay, well, that one is pretty good. So I'm happy with this. I'm not gonna mess with that anymore. So then I'm gonna move to the front one. Okay, so we know there's a play in the front one, right? So there's the play. So I'm gonna tighten this. All right, hold my Allen wrench and my wrench, and I'm gonna tighten. Nice to a place that I feel it's good and secure. And I'm gonna check again. Voila, see? Problem solved. Now it's all good. Right, so now I'm going to create the second scenario where it can be as well. So these two lock nuts here at the ends of the cylinder, that holds the cylinder nicely in place with the rod ends. So this is very common for those to go loose over time. And the reason for that is a lot of times it's just the roads are, you know, vibration. You get on a plane, the vibration of a 10-hour flight on a plane, or numerous factors, or you could have played with it by yourself and you didn't tighten it well. So I'm just gonna make as if this one was the issue now. So I'm gonna turn the cylinder so it's out of position. Okay, so over time this happened and you didn't notice it, but you're gonna feel something is not good there. The steer. And the more you push, the longer you go on without fixing this, the more the cylinder is going to turn slowly. You're not going to notice, you're not going to see it until it gets long enough and it's going to start pushing the fork arm forward. Once it pushes the fork arm forward, it's going to push your front wheel in and your chair is going to go to the left and you cannot think, why is it going to the left? And then you're going to go look and you're going to see that might just be the issue. So you're going to go back and you're going to start spinning your cylinder slowly in the direction of this lock nut. And you see, okay, don't move the lock nut because the lock nut is not the one that usually moves by itself. It's only the cylinder that will move. So, and then once the shoulder to shoulder there, you're going to hold on to the lock nut, to the cylinder, and you're going to squeeze down and tighten the lock nut all the way against the shoulder of the cylinder. So this might actually be the same issue in front as well, but in this case we only use the back, so you can check either side. Okay, now we're all good again, right? Now the third one is the magic that happens inside of the cylinder. You know, so we know this. Daniel explained us very well what's going on in there. I'm not going to go over all that again, but if these two lock nuts here if they're not in the exact position, there is a play inside somewhere. So the magic is not working. It's not magic then anymore. And that's just very frustrating, but it can happen. So I'm gonna create a scenario here again where I'm gonna loosen. I'm just gonna go a half plus maybe a little bit more. Okay, let me see. All right, here we go. Okay, so now, listen there. Kind of a sound right. And here, right here, you can actually put your index finger and your thumb, and you'll feel there's movement. And that is that little play. That's the little play that's caused because of those two lock nuts are not in exactly the right position. So you're gonna go back, and you're gonna use your your 2 wrenches, and you're gonna go not too much, okay? Just do 1 turn tighter. Usually first try tight, tighten up a little bit, and voila. Okay, so that is fixed now back to its good original position where there's no play. But in case it is too tight, I'm gonna go make it too tight now, right? So there you go. There you go. There's quite a big play actually now. You can see in the steering as well. Look how the steering is moving. There's no engagement until you hit a little bit left or right. So that is too tight. So we're gonna go back to the magic position, which is not too tight or too loose. All right. There's still a little bit more. So I'm gonna go a little bit more. And I think we're right on. Okay. Now you can see there's no play. Everything is in a good shape. Don't mess with it again, but check it every once in a while. Make sense? All right. Let's go on to the next topic. Is that Daniel?
Some great information there, Craig. Because I've been talking about this default direction, but if there's a bunch of play in the cylinder, that really doesn't do us much good.
Yes. Yeah, you're totally right.
So I want to talk about this back here, and this is the anchor point for that cylinder that I've been talking about, and I've wrapped it in a little bit of red tape. And if this were fixed right where it is and not allowed to move, that would only give us one default direction, because that would hold the fork arm exactly where it is and thus pin the wheel in that one position. And that'd be okay for half the time on a track, but I'd have to, half the time I'd have to be steering around the turns. And so this is where actually it is a great thing that this anchor point is not fixed. If I interact with this triangle here, which is the track control or the compensator triangle, you can see that anchor point will move. And so if I hit it on the left, and I'm not sure exactly what way the camera is right.
It's actually showing it right.
It's
correct now.
Okay.
Correctly.
Good. So we're viewing it from the chair from the underneath right now, and so our directions may be flipped. So if I hit it on the left, that is going to move that anchor point forward, and that's going to move the cylinder forward. But that cylinder is not going to change its overall length because of that spring on the inside. And so that's going to transfer all that motion directly to the fork arm and turn the wheel to the left. If I hit it on the right, that is going to draw that anchor point back and again, draw that cylinder back. But again, it's not going to change length because of the spring. So it's going to pull this fork arm a little bit back and turn our wheel to the right. And if you go right between the two, ideally, your chair will be going in a nice straight line.
If your camera woman could handle this, it's backwards and I can't do this well. So it looks like you can change it back and forth. Do you have to hold it? Like, was it going to stay there kind of thing or what?
So yeah, it will. So if I hit it on one side, it is going to stay exactly where it is because of the mounting mechanism on the compensators triangle is going to create a lot of friction between that triangle and the main beam. So if I interact with it, it's not going to move until I interact with it again.
Okay, so it's not like wandering all over on its own. Okay, that's a good thing, I guess. All right, so now you got this range, which is great. Yep. How would I know, like, say I want to go in lane 1 versus lane 8 on the track. So yep. I think lane 1 needs more turn than lane 8 does. So how would I know? Do I have to fiddle with that while I'm on the track? How do I know how far I'm turning?
Yep. So this is probably easiest to explain if we were just trying to look at this from over top. So I'm actually going to to explain this like I'm looking at it over top of the chair instead of underneath the chair. So you can see that I'm screwing in these thumb screws here. And so these thumb screws will actually limit the amount of turn you can get out of the compensator. And so you can see that it is, they're hitting this plate right here. And so I am limiting the amount of turn that I have. So this amount of turn may be good for, say, lane 8 around the track, but I would need to undo this thumb screw in order to get a little bit more turn if I wanted to go in, say, lane 1.
And so this is flipped from the way his compensator normally goes. So it's
Yep.
looking backwards, but.
And so, but on the right side, for going straight, I actually want pretty much no right turn at all. And so I'm going to screw that thumb screw in until I've eliminated all of my right turn.
Okay, so you can hit it all the way on the left to go around the exact amount of turn, as long as you have set that before your race, right?
Yep.
And know you're going to stay in that one lane, and then hit it on the right to go exactly straight and not go
Yep.
in front of somebody else. Okay, so that sounds good. So if you were like in a 400 and you had it adjusted right, you wouldn't ever have to touch your steering then
Yep.
to go on a 400.
That's
right?
correct.
So, but what if like somebody stepped out in front of you, or like you were on the road and you wanted to make a right-hand turn or a left-hand turn? That's not enough turn, it doesn't look like, to do that you're getting out of the compensator.
And so that is probably best to just view from over top. And so that is when we are going to use the steering tube here on the top. And so if I wanted to turn left, I'm going to push the steering handle or the steering tube on the left, and that is going to pull this fork arm forward and pull that rod out of the housing. And so I can get a lot more range out of that kind of, or using the steering tube than I can just using the track control. It's the same thing if I wanted to turn right, well, kind of opposite, sorry. I would just pull on the right, and that would push that fork arm back, pushing the excess rod here into the housing. But one important thing that I want to note here is that if you'll notice, it always returns right back to that same position, no matter how far or which way I push it. It is going to return back to that default position after you are done steering. And the second thing is that I don't know if I'm holding the right, yep, that is the right part of the chair. So the anchor point will not move when you use the steering tube. And so you will go back to the same exact 0 that you had before you attempted to steer.
Okay, so you don't have to reset your default afterwards. No, but I've seen people on the track who seem like they've spent a lot of time setting their compensator and everything, and then for some reason they touch their steering and it seems to move their track control underneath there, and then when they let go of the steering, all of a sudden they're not going the way they thought they were going, and that seems to lead to a lot of frustration, which I can understand. So I think, Krieger, you're gonna explain this, right? Kind of what's happening there when that track control seems to have a mind of its own.
Yeah, that is an important issue to deal with and to know how to handle it. But I love the idea of having that, like I showed Simon and his friend this morning, and they said that the track control is almost like a cruise control. I just wish my arms had a cruise control so I can be in that position as well. But so anyway, when you have your track control and you go in the curve and your front wheel keeps on going to the right instead of going into the curve, your front wheel wants to go straight. It means like that your track control, the nut underneath your track control is not tight enough. So you have to always make sure that this fixing point, this point underneath, there's enough friction for the nut to hold the track control in position, so that when you turn, when you use your steering, it doesn't override on your track control. So let's play with this a little bit. Okay, so I'm gonna grab a wrench again, right here, and see this big nut here. That's the lock nut for the track control. So I'm gonna tighten it. I loosened it a little bit earlier, so I can give you an idea. So I'm gonna give it a nice good one here. Put a little bit of a squeeze to it and see what it does. Okay, so it's already stiffer. Okay, so there you go. So now feels like there's friction, and when I use my front wheel, it seems to be okay. So that, I mean, the steering, the track control is moving. So once you have that in place, there's two little set screws on the side here. So you're going to be sure that those little set screws, one on each side, you're going to be sure that they are nice and tight, because they hold, I need my glasses here, but anyway, so they're going to hold the nut in position. Okay, so there you go. So now I think everything is nice and together, and you can go back on the track and you can do your workout well, and you can be ready for a race. But this is something you can check often. It's this with a top end chair. Every chair is different. So if you have a carbon bike chair or eagle chair, they're all different, but the principle is the same, is to keep this track control nice and tight, and so the chair would run in the line that you set it in. Good. What's next up? Tuning. Are we going to Adams now or not yet?
Am I not unmuted? There we go. We were going to be doing a little track simulation here. Daniel has some lanes in his living room, but unfortunately, the fact that our thing is flipped from side to side, I know, right? There's not much furniture in this living room anyway. It didn't take much rearranging, but the fact that our video is flipped side to side would make it highly confusing to talk about the adjusting it on a track. So we'll have to make a video of that and post that later. I'm sorry, when we practiced this, it wasn't flipped around. So a technical difficulty here. So I think what we want to do at this point is actually, Kriga, if you can talk a little bit about that. It looks like we have time to talk about the position of that clamp on the front end of the cylinder where it attaches to that fork arm.
Oh, good point.
And
yes.
what that does.
Yeah. Okay. So when you are in your racing chair, and I'm going to have my cameraman come up a little bit closer again, and come on behind me, Simon, so you can give us a good line to the front of the chair. Okay. So if you are in your racing chair and you sit in the chair and you steer and you move your steering left or right, and you feel, oh man, this is just too tight for me. I cannot handle it. So some people like a softer feel, and some people like to have a lot of tension here. So one thing you can do is to move this clamp inwards a little bit. If you move this inwards, the steering gets softer and easier to turn. The one thing you have to make sure is, if you do move it, you got to be sure to tighten it. The clamp has to be nice and tight again, because otherwise it's going to move. So the more in you bring it, the less of a leverage action is here. So the further you come out, the longer the leverage, so the stiffer it's going to feel when you steer. Nothing is going to change inside here. Everything will be the same. It's this angle here that gets more or less. Okay, so I'm going to move this out a little bit, and we're going to see what it looks like when it's really easy to do this. Okay, let me see. I'm going to grab the nut at the bottom to hold, and the Allen wrench from the top, maybe a little bit more to get it nice and loose. Okay, so I'm going to move it in just about, let's go about a 1/2 to a 3/4 yeah, about a 3/4 inch in. Okay. So just be sure when you tighten it now, keep your clamp level so it doesn't, you know, point up or down. And then you're gonna grab your Allen again and I'm gonna tighten it, nice, and make sure that is tight, really nice and tight, because you don't want the clamp to move or to shift while you push. Okay, let's see. Okay, now this actually feels a whole lot softer for me than the original position. So try this if you feel like you need to do a little bit of adjustment to it, but just don't go in too far. You want to stay about, not, I would say, an inch at the most, maybe just a little bit over an inch, where if you feel like you really need more of a turning or a softness to it. Okay, I think I've talked a good bit about all my gadgets. I think I've covered all that I needed to. It's about time, yeah, it's about time to go to something really special. You know, if you look at all this, you can see what's going on here, and I can explain to you the mechanics of it and how it works. And but lately there's been a lot of new technology, and I've got a good old friend from South Africa. We used to start racing long ago. We raced a lot together, and when I was still in South Africa, and now he still comes to visit us here, and from time to time he comes stay with us here in Rome or in Atlanta. Ernst van Dijk, he's got something to share with you guys, and I'm gonna let it over to him.
Thanks, Craig, and thanks for having me on the show. I think it's really important what you guys are covering here, and a lot of the beginners out there and the starters in the sport, they will be amazed about how many professional athletes on the scene don't really know how to look after their chair and how to do this and what's being explained here. This is a really valuable tool, and I hope a lot of the youngsters and the up-and-coming athletes will use this resource in the future. So we have a lot of good wheelchair mechanics out there at the races who can help those old guys who don't know how to fix their chairs. And I have some good stories, about how this seems to fail you at the most critical moments in your life when you don't expect it to. I remember there was a race in 2004. We were doing the trials. Back in the day, they used to have an exhibition race at the Olympics, a 1500 meter on the track for the men. And it was in Atlanta. It was exactly this time of the year. It was in Grady Stadium. We were doing the last 300 meters of the 1500 meter race, the trial race. You had to be in the top 8 to qualify to go to the Olympics and take part in the exhibition race. And I was in the best shape of my life in those days. And as I was coming up to that final bend, 200 meters to go, I hit my compensator, and that lock nut that Krieger was talking about at the bottom had somehow loosened, and I hit the corner and I just went straight, and the pack went around the bend, and I finished last and didn't make that very important exhibition race. So it shows you, even the guys who are supposed to know what they're doing, sometimes we do neglect to pay attention to the details, and we pay dearly for it. And that's just a story, a good one to remember. Coming back to the advances in technology. So about 2013, I approached Honda, and I've been keeping an eye on their developments in the carbon racing chair that they've been doing over the years. And then they've been working on this chair at that point for more than 10 years. And I decided I was coming into the final years of my career, and I probably want to give it a shot and race with a full carbon racing chair. So I approached them and I said, I'd like to buy a chair. What's the process? And they said, no, you don't have to buy the chair. If you work with us to improve the chair we have, we'll sponsor you and you can have it for free. And I was really overwhelmed, I was over the moon, and I would get a full carbon racing chair. And once I started using it, I realized that even though it was extremely aerodynamic and the fit was perfect and everything was great, it still had this cylinder on the outside. It had this compensator and the arm on the fork. And I was just thinking, and I was telling them, look, you have this incredible aerodynamic frame, but you've got this thing sitting here on the outside of it that, number one, for me, is exposed. If you're in a crash, whenever you're in a little bit of a crash or a dingle, that is the thing that will break. The arm will break off, or the cylinder will bend, or one of those keyholes things will bend. It's where it goes wrong. And I said to them, why can't we put this on the inside of the frame? You have a carbon fiber frame, which is a shell, it's hollow. Can't we engineer this to fit inside of the frame? And they started working on it. And the work became a bit frantic because I pushed them that I would like to use it at the 2019 Boston Marathon. I wanted to use it. And eventually they came up with an idea. And if we can go to the next slide, they were able to, take it to the point where all of these mechanics that Krieger and Daniel have explained to you, the spring and everything was in the headset of the chair, but they still needed to connect it to the compensator, and they had these two links on the outside. And although this was really nice and it was a great step in the right direction, to me it was still not perfect because we still had something on the outside messing up this great airflow that we have around this very aerodynamic carbon frame. And the guys kept on working. And if we can go to the next slide, somewhere last year, they finally came out and they said, we've done what you've asked, we've put it all inside. And if you look at that, all that you can basically see is two little holes where you attach, and they've moved away from having the spring in the headset, and they've gone back to having a cylinder like Daniel and Krieger explained to you guys, but now the cylinder sits inside of the frame. And if we can go to the next slide, you can see the front view, and you can see it's an extremely clean looking frame from the front. There's absolutely no play on the system. If you touch that front wheel, there's no wiggle, there's nothing. We go to the next slide, and it's a close up. It's an extremely nice looking thing. The problem with this is it's quite technical to service, and I'm very experienced, and I always try, and when I get new toys, I take them apart and I make sure that I know how to put them back together again. And that's one of the first things I did with this new design. But I can tell you, you need really good mechanical skills, a bit of luck, and a good eye, and a very good flashlight to be able to service this and to keep it in good condition. Is it worth the price? I think so. I think, the clean airflow that we have over it, the fact that it's not exposed, when you travel with a chair, it doesn't get damaged. To me, that was something that we strived towards. And this is just a next step, in the technology. Who knows where these chairs will be in the next 10 years and what it will develop to, and what the up and coming athletes of today will be racing with. And I was just happy that I could play a role and, go to the final slide in pushing the guys, to develop a chair where when you're sitting in this cockpit and you're looking to the front, all you see is clean air, and that thing's going to slice through the air when you go downhill or get a good top speed, and it's going to perform the way you want it to perform. So it was a big leap for them. It was a huge investment in time and R&D, and we went back and forth with a lot of ideas to get it to where it is now. But even though today it's an ongoing project, we are continuously looking for ways to make this better, to improve it, and to make it more durable. I don't know if Krieger or Daniel, if you have any questions on this for me. That's basically what I have to say on this. I love this chair. It's incredible. I was so looking forward to racing this chair this year, and it looks like we will not have a single race, and I'll have to wait for 2021 before I can really test it with some other athletes.
I have a quick question, if you don't mind, Aaron.
Sure.
Wow, yeah, that's quite amazing to have, to see what we started with in the late 80s, early 90s. What a long way it came, right? Man, yeah. But I want to know, Ernst, if you can think of one thing that you would like to improve on that chair now. Are you willing to share that with us, or what's the guy's next step?
I think what we can improve is we can still improve on the front wheel technology. I think the front wheels are basically still the same type of front wheels we've been racing with for the past 20 years. I remember when we started out in the 90s, we actually had some tri-spokes carbon fiber front wheels, and later they moved to the deep section. But I still think we can improve on the front wheel and the bearings and the play we have on there. On the frame, I think pretty much what Honda has done is fantastic. Maybe the steering handle, we can make it more aero, we can clean it up a little bit, but steering handles are so custom. And a lot of the athletes, everybody has a different feeling or a different thing that they want. These guys want vertical things, these want horizontal things. But so it's going to be really, I think with 3D printing, it's opening up a lot of doors to maybe customize really nice aero steering bars for athletes in the future. I think what we've done with the disc wheels, and one of the challenges I put to the guys was I said, look, we're using disc wheels that were actually made for cycling, and we put a push rim on it. I think we can make a disc wheel specifically for wheelchair racing with the forces in mind that is applied to a wheel when we are wheelchair racing. And the guys have actually come up and they've designed a really nice disc wheel. Of course, they are expensive, but it's about volumes. When you look at the other disc wheels selling, there are lots of them selling. When you look at the Honda wheels, of course, there's not a lot of them selling. And we've had a lot of man hours to develop these wheels, R&D testing to get it where it is today. So you pay for something extra. You pay for some new technology. So I think where we are at the moment, I'm not sure if the technology exists at the moment to make the chair better, to make it faster. Maybe to make it lighter, it's possible. And I'm a heavy guy, so my chair is not as light as I would like it to be, but you're working with carbon fiber, you're working with the shell, and you're working with a huge surface area. So maybe, that can be improved in the future. But besides that, I think it's as perfect as it can be for me today.
Very good. I think I'm speaking, coming through here. It's an incredible piece of equipment there. And obviously we're dealing with a wide range of athletes. And so we've got, athletes who are just beginning all the way up on to the very top levels here. And there's a right chair for everybody and a right time for everything. So some of the questions that I'm seeing coming through are, okay, how would you get one of these and what's the price? Because obviously along with this technology and all these man hours, there's got to be a price tag on this.
It is very expensive technology, and it is also quite a process to get it, because the chair is made as any racing chair, custom made for the user. And in the end, you basically have to take a trip to Tokyo, and you need to go with your existing racing chair, and they put you in a machine where they 3D scan you to make sure they capture your dimensions and the position in your chair. So first of all, you need to be at a place where you are truly happy with the position that you have in your chair. It needs to be perfect. They then scan you, and then it takes them about 3 or 4 months to develop and design your carbon fiber frame, looking at the stressors on the frame and where the forces will be applied and where they need to layer up more carbon fiber and where they can layer less. And that takes a lot of man hours and time. The chairs are commercially available. I think the price tag is somewhere in the range of $25,000 for a chair, which excludes wheels. So it's a very expensive piece of kit. But what I like about it is I could use the same chair if I don't have a bad crash for around 5 years. Where with my aluminum chairs, I used to get a new one every year, because I knew with traveling and vibration and the forces on the aluminum and the welds, they do wear out and they do become weak. So I felt as a professional racer and somebody competing a lot, I wanted to have a new frame every year to make sure it would hold up with the season. With this carbon fiber chair, I'm pretty comfortable that I would be able to get 5 years out of it and it will stand me up well. So there is a calculation to be done, but it is still quite expensive. And I would recommend it for somebody who knows exactly how they want to sit, what they want, and that they really want to make a career of the sport.
Gotcha. Yep. So that's it's really cool though to see that technology, because eventually there's a trickle down, right? And the things that were revolutionary at one point become standard. We're just at that revolutionary standpoint right now. So probably
Yeah, you know,
not.
Kim,
Yeah.
sorry to interrupt you. Interesting enough, like Daniel is using a top-end hybrid chair, the NRG, and currently Honda is using all of these R&D that we've done to develop a hybrid chair. So you will get all these nice benefits of having the integrated steering inside of the main tube, and then you will have the clamp-on aluminium seats like the hybrid chairs are using at the moment. And of course, that will be way cheaper than a full carbon chair. So as you're talking about the trickle down effect, that is the trickle down effect, where these developments that we've been working on becomes available in a hybrid chair. And then, you know, somebody can get the main frame and maybe get a new cage every year, and it's going to work out a lot cheaper for them, but they have the benefit of that integrated steering and that really nice airflow on the front of the chair.
It's always interesting to me to hear the stories of how all this stuff developed. I'd love to hear at some point. We have too many questions to cover right now, but to hear from you guys, you know, how did the cylinder idea, you know, first develop? How did that change over the years? And I'm sure it did at some point. Neat to see this stuff happening. So let's get some of the questions, because we do have quite a few here. The first one, to get it out of the way, Daniel, this is to you. Do you not use springs on the thumb screws to limit unwanted movement? We had this discussion earlier.
And so this was just for the demonstration. So I did not have them fully assembled. But yes, I would have you know, springs. I know I think some manufacturers use just some 2 wing nuts. But yes, I would have something to limit vibrations and unwanted movement in that thumb screw.
Yeah, you don't want that thing that you spent all that time setting just perfectly rattling out of position, right? Yeah, I think we just were able to show a bigger range of motion, so you can see that anchor point moving better without those springs there. Okay, let's see here. Question: if I move the cylinder further out on the attachment, I think that means the fork arm, to make it stiffer, will that turn my turning circle bigger or smaller?
Shall I go for this one?
Yep.
Yes.
The further out you go, just in short, yeah, it will be a shorter turning radius the further out you go. The more in you go, the tighter you'll be able to turn, and the softer the turn will be.
So, Kriega, I was having to move around while you were presenting some of that, and I'm not sure if you talked about it or not. Is there any other way to make it stiffer as far as the steering is concerned, besides moving it?
No, that's the only way. Well, there is one more way. If you can add a different spring inside the cylinder mechanism, and those are available for if you want to, you know, have a little bit of a more stable front. But the best is just to get another whole new cylinder, rather than, you know, changing out because it's probably going to be hard to find those springs anyway. But yeah, one of 2 ways: move it out or get a stiffer cylinder.
Very good. Okay. Let's see here. Some questions about using, a couple of them, about, do you guys ever use the track control on the road? This is, so yeah, I think any of you could probably go for that one. Ernie, how about you?
Yeah, of course. We use it on the road because most roads camber out slightly because they need to direct the water away from the middle of the road. And of course, if you're just going to put a chair down on the road to go straight with that camera of the road is going to pull to the left or the right, depending on which way you're going. And we use the compensator to compensate for that pull, to make sure that you don't have to body steer or correct your steering all the time when the camera of the road is pushing you to the side where it's flowing or leaning towards. So yes, it is a very important little piece on the road. And of course, on the road, we also have corners that we can actually push through. And if you use your compensator through those corners, you can push while other guys need to steer. So it is a valuable technical skill to develop, which is how to use your compensator on the road.
I can chip in here as well. I remember doing a Detroit marathon, and there was a really strong wind on the island somewhere there, and I used just a crosswind. It was a brutal strong crosswind, and I used my compensator just to point my front wheel slightly into the wind. So because the front wheel was just kept on pushing away from the wind direction side.
Very good. That makes sense. That may also, and I'm not sure, Henrik Kuhl, I have a question here talking about on a straight, on a road, my racing chair pulls slightly to the left. How do I adjust? And that may depend on which direction your roads travel. You may have been talking about, my guess is the going maybe the opposite way that we would in the US as far as roads are concerned. Because I think on a typical US road, you guys correct me if I'm wrong, but the way that the crown of the road is, that's going to actually make you usually pull to the right, correct?
Correct, yep. Mm-hmm.
Yeah, okay. So we would basically, you want to aim it, you basically want to overcorrect for that kind of, instead of just going straight, you want to go a little bit the opposite way that you keep on pulling, I think is the deal there. But I think that one is probably just a road direction difference there. Okay, so this one it kind of gets into setting up your track controls for a track event, and this says when you talk about the lane assignments and trying to make sure that you are in the aligned correctly, you have those limits set correctly for the turn and such. Do you have any hints about doing that when you can't get out onto the track beforehand? So you've got two different events, both of which maybe say you've got a 400 and an 800. So you're in different lanes. And that 800, a lot of the time you're going to want to be in lane one. But maybe you draw, a different lane assignment for the way out on the edge, or your 400. You don't have time to reset it. Any hints on that? Daniel, what do you do what would you do if you didn't have time?
One way is I kind of do know how much of a revolution of a thumb screw is per lane, and so I can get a good guess at what how far I'm going to need to adjust my thumb screws. However, say for the 800, where you start in a lane and then you can move into lane one part way through that race. I set my compensator for lane one, and then I do not fully hit it around the turn when I'm, sorry, no. I do fully hit it around the turn when I am, man, it's been a long time since I've been on a track. So what I would do is I would set my compensator for lane one. And then when I am coming around that last turn to get at my starting line, I would only partially hit my compensator so that I am not fully in that lane one, and so I'm not being pulled in towards the center.
So I'm thinking usually you get one warm-up lap right? Is that
Yes, yep.
the
Usually
case? So,
one warm-up lap.
so you can get in that lane that you're assigned to for the start
Yep.
on your warm-up lap and don't hit it fully. You're not adjusting your turn for that. You're just using that range in between and getting that so that you, on the start, you can be in between your limits and stay in that turn, I think, right?
Yep. So I've just half hit the compensator to get into the correct lane assignment for the start, but have the end of the thumb screw adjusted for the lane one.
Gotcha. So then you can hit it harder.
I can give you a little story here what happened to me as well. Like Ernst was telling earlier about his compensator. So when your compensator is not set right, if you don't mind just telling this, Kim, it was in the Paralympics in Sydney. The final lap of the final 400 yards of the marathon was on the track. And I was just behind Heinz Fry, and Heinz' compensator wasn't set for the track. And that cost him a second place in the marathon. I was just behind him, and he hit his compensator, and I think it was not set far enough, or it was set by too much. So he missed making a silver medal, and I was able to jump in on that.
Yeah, things hitting the compensator, and even when you hit it right during a pack, if you guys are in a big pack and you're coming into a turn, I think Daniel, you had some experience with some issues with that in London, right?
Yep. So when you've got a big pack going 20 plus miles an hour, riding inches from each other, there is not much time to react to anything. And so if one person doesn't quite hit their compensator at the same time as everyone else does, things can go very wrong.
Yeah, you can have bowling for chairs there, kind of thing. Yeah. All right. Well, thank you so much. First off, Ernst, for joining us and showing us the cool future there, and for Krieger and Daniel. And I think we're going to turn it over to Lily here.
Awesome. Thank you, Kim. Thank you guys so much for joining us, attendees as well as panelists, Daniel, Ernst, and Krieg. I'm blown away with all of your accomplishments, and to have you guys all in this webinar is so great. It's cool to see what the future of technology is going to look like, and we appreciate you guys being here. With this said, this session has been recorded, as well as all of our sessions have been uploaded to YouTube underneath Move United, and we'll also send a follow-up email with the link to watch this video again. So it's been a great resource so far. We are really looking forward to having another session next week, July 9th. So Thursday, July 9th at 4 p.m. Eastern Standard Time is when we'll be talking about wheel alignment. And again, that session will be recorded too if you're not able to join us. But thank you again for being here, and we look forward to seeing you next week.